Hey guys, welcome back to the Geography Academy. Remember, this video is just a small part of a much larger course that's available below if you just follow the links and instructions. Section 4 of this unit is going to be mass movement. Earlier on, I did have it down as there only being 4 sections, but there is in fact 5. I forgot to mention mass movement. So mass movement then is a big part of it from AS going back to rocks and weathering. It's recapping quite a lot of that with a little bit extras in terms of like how to deal with hazards. Shear stress then, looking at the force in an area, and that applies more force onto the downwards motion of a slope. The shear strength then is the internal strength, and if that's being reduced from inside, this is going to cause then potential for mass movement to occur. So usually a slope is in an equilibrium, so this is going to change that equilibrium. So shear stress occurs when it exceeds the shear strength. So either can change. Then the factors that contribute to this, the reduction of shear strength is going to be the weathering effects, so chemical, physical, and mechanical weathering. Pore pressure then with water introduced into the pores and a change in the structure, weaknesses or abundance of water changing the actual structure of it. And then organic effect or biological weathering also can deteriorate it, so things like vegetation, for example. Sometimes vegetation, though, can cause an increase in the shear strength, like roots binding the soil, which is important to mention too. The overall stress then could be undercutting, like through erosion, removal of underlying support, loading the slope as well, extra weight, building on top of it, artificial like buildings, lateral pressure. This can come from physical weathering here as well, external pressure then from there, and yeah, this can cause an issue then inside. The transient stress directly links back then to things like earthquakes, where we can see seismic waves then causing transient stress throughout the slope and causing mass movement like we mentioned earlier. So downwards force then opposed by things like friction, cohesive forces, and vegetation. So anything changing that will interrupt it. We have different types of mass movement. We've got our flows. We have the mud flow, rapid movement, with an increase in the amount of water that's in and mixed with the soil. So mud flows then we can also kind of relate back to the concept of lahars, so high water volume with lots of debris mixed in together. So usually fast flowing is identifiable then with quite a narrow trail and quite an elongated profile as well. So it's going to move very far and have an extended lobe out the front where it continues to move after it's past the higher gradient areas. Earth flows then, mud flows would look similar to this, but would be maybe just a little bit more narrower in the middle and then expand out a little bit more at the end. The earth flows then will have less moisture, it will flow maybe over less space, but could be wider and can churn over maybe a deeper amount of sediment as well. So again, this comes with saturation. It is another flow as well. And the material moves in a similar way, but will be a bit more viscous in its motion, and that means it's a little bit slower. Slides then occur as sections of the rock or of the slope are going to break off together and move as singular pieces. This is why we can see evidence like in this one here, for example, that this area has stayed a bit more intact because it's slid down then as a single piece. So the slides then can go down in blocks together, and this can be triggered by earthquakes. And what we often find is that there's going to be some strata or layers of the rock, and those particular layers then are weakened. So the top one, for example, might cause like waterlogging along the bottom, might have weathering that's loosening it all the time, and that way it's just going to move down all together at once. So often a rock slide or a landslide then is dictated by the geology as well as the other factors surrounding it. Slumping then is going to occur. Rotational slides are going to occur because you have an area potentially of like the slopes here. So inside that slope, you might have areas of permeable rock that's underneath, And we might see things like waterlogging occur, where a lot of moisture is going to build up over the permeable rock here. A lot of weathering is taking place, and perhaps erosion as well on the edges here. So with those mixed combined, what happens is the front of it will move out, straight out, and will slide out there, while the top of it then will break into chunks and will move downwards, occupying the space of all the land that's slid out from underneath it. So this creates a slumping process and a rotational slumping scar like here. Falls then occur, like rock falls are going to occur because you have broken down into pieces, sections, different pieces through like weathering processes. And this allows then the rocks to be broken into several sections. They crack open up and fall due to gravity. So you can get